Sir, shall we start, sir? Really lovely.
Sir, good morning, sir.
Sir?
Am I audible?
Yes, sir. Audible, sir.
Okay.
Sir, shall we start, sir?
Sir, shall we start, sir?
Yes.
Very good morning to everyone gathered here. I feel privileged to extend my warm welcome to all gathered here for a AICTE sponsored 6 days online short-term training program on emerging trends and research challenges in a next generation wireless network, organizing by a Department of Electronics and Communication Engineering, Kongunadu College of Engineering and Technology. Welcome you all. Sunshine is a welcome thing. It brings a lot of brightness. In this way, I would like to call upon Dr. M. Dharmalingam, HOD, Department of ECE, to deliver a welcome address. Please, sir.
A very good morning to all. So I am very happy to welcome for this phase 2 emerging trends and research challenges in next generation wireless networks phase 2. So already last week we completed the phase 1 2 weeks FDP program in 5th generation VLSI design. So now this is the phase 2 for next generation wireless networks. I am very happy to welcome our principal and coordinator of this program. And today the forenoon session also going to handle by our principal. So I am very happy to welcome our principal, and I'm very happy to welcome participants from all over India, and our department faculty and students for organizing this phase 2 next generation wireless networks AICT sponsored STTP. I am happy to welcome once again all. Thank you.
Thank you, sir. If your actions inspire others to dream more, learn more, do more, and become more, you are a leader. In this way, I would like to call upon Dr. R. Ashokan, Professor and Principal of Hungnadu College of Engineering and Technology, to deliver an inaugural address. Please, sir.
Good morning, participants. Next generation wireless networks. So it is actually we plan to organize in our college. So we are organizing through online mode. So already first. So compared with first phase, phase 2, we received more applications. Joined this entire 6 days. So going to discuss with first session start with the resource persons from industry and reputed institutions going to deliver the in-depth concept of wireless networks and research. Please attend all the session, because based on the attendance and in the final examination, the certificate will be issued. Will be posted in the chat box. So you have to immediately submit the feedback and attendance form. So like that, it will be for all the sessions. So in the final session, again, overall feedback and attendance certificate will be issued within 1 or 2 days. So I think classes also may be there for many participants. So maximum I request all of you try to attend. So all in this occasion, I'd like to welcome once again all the participants, the HOD of EC department, the organizing committee, technical coordinators for this program. And also I'd like to thank AICTE for sanctioning this SCTP. So already this year they have sanctioned 2 STTP, 1 FDP and 1 ATAL FDP program. So already 2 program successfully completed. So 2 program, 2 week FDP and this STTP, it's AICTE for sanctioning these programs to our college. Thank you.
Thank you, sir. Every thought you produce, anything you do, it bears your signature. In this way, I would like to call upon Mr. Rakesh to give a short intro about our today's resource person, Dr. R. Ashokan.
When life puts you in tough situations, don't think why me, think try me. The most suitable person for the above quotes is our today's resource person, Dr. R. Ashokan. He received his UG degree in Electronics and Communication Engineering from Kongu Engineering College in 1988. He completed his Master of Science in Electronics and Control from Birla Institute of Science and Technology in 1994. And he received his PG degree in Electronics and Communication Engineering from Pondicherry Engineering College in 2001. He completed his doctoral degree in Information and Communication Engineering from Kongu Engineering College in 2008. He has totally 32 years of teaching experience. He is an associate editor and editorial board member in 9 international journals. Also, he is a reviewer in 13 international journals. He acted as chairpersons and delivered special lectures in many international and national conferences and workshops and organized more than 35 FDP seminar, workshop, and conferences. He did several projects in his career and got 3 patents during his curriculum, and also got copyright for a mobile application for mark analysis. He was involved in several consultancy work and sponsored research. He is a recognized supervisor in Anna University, Chennai. Under his guidance, 9 candidates completed their PhD, and currently 8 research scholars are doing PhD. He has published more than 76 international journals and presented paper in 88 national and international conferences. He received Best Paper Award in various conferences and received Rajiv Gandhi Educational Excellence Award for outstanding achievements in the field of education by International Institute of Education and Management, New Delhi 2012, and received award for Best Community FM radio station for community radio services in India for the year 2008. He also received Best Teacher Award during the year 2003 to 2004. He is a professional society membership in IETE, ISTE, ACS, and CSI. There is no limit for his success. Now, I request our resource person, Dr. R. Ashokan, to deliver his speech on the topic of Introduction to Wireless Networks. Please, sir.
So thank you, Rakesh. The first session is going to introduction to wireless networks. The wireless networks and signal propagation. So how the wireless signal propagate, and particularly in the wireless networks, mainly the digital modulation and multiplexing techniques are important. So what are the digital modulation and multiplexing techniques used, and what are the IEEE thing, and the types of wireless networks. So because many participants are AICTE background, so the first session will be the next sessions will be followed by the other resource persons with the various wireless networks and the research issues. So basically, before going to the detail of wireless networks, so the electromagnetic spectrum, in particularly for wireless communication, for each and every application, so already the license is given, and also for each application already particular frequency is allocated. Suppose if you want more bandwidth, means it is not possible to extend the bandwidth, so we have to go for or encryption decryption techniques. So just we want to see the what are the classifications of frequencies. So very low frequencies starting from 300 hertz to 30 hertz. So and our audio frequency is 20 hertz to 20 kilohertz. Our voice frequency 0 to 4 kilohertz. So normally when we are talking music, it lies within that very low frequency. So that's why we cannot directly send the signal to the long distance. And a low frequency range from 30 kilohertz to 300 kilohertz. And medium frequency 300 kilohertz to 3 megahertz. So currently in our country, many AM radio stations are operating in medium frequencies from 300 kilohertz to 3 megahertz. So mainly in the range of 990 or 995, 1010 kilohertz range. Many radio stations are operating in that. That's how it's called as a medium frequency radio station, not FM radio station. And high frequency from 3 megahertz to 30 megahertz. So very high frequency. This all the FM radio stations are operating in the VHF. So normally from 110 in that frequency range, so FM radio stations are operating, and UHF range 300 megahertz to 3 gigahertz. Super high frequency, it is 3 gigahertz to 30 gigahertz. So extra high frequency 30 gigahertz to 300 gigahertz. So then after that, so up to this communications, then optical range 300 gigahertz to 3 terahertz. So there the infrared is there. Then after that 3 terahertz to 300 terahertz, there visible light. Then after that ultraviolet light is there. So here in that range we are using for optical transmission. So optical transmission normally we will mention in terms of nanometer. And 1550 nanometer is used for optical transmission. And the twisted pair, it's a very low frequency range, starting from 300 hertz to nearly 100 megahertz. Similarly, coaxial cable starting from 3 kilohertz to, so up to some few gigahertz it is going to operate. Then after that, if you want go for wired communication, means only it's the optical transmission is possible. So application starting from medium wave radio, FM radio, then cell phone communication, and for other Bluetooth like this. So separate frequencies allocated. So it's a natural. But in the case of wired communication, if you want more bandwidth, you can put more coaxial cable or more optical fiber cable. You can increase the band increase. So only option is improve the efficiency techniques like that. You have to go for efficient techniques. Then only you can improve the bandwidth or data rate. So the comparison wired with wireless networks. So speed of operation. So wired network is higher. It's wireless networks compared to wired, it is low, and system bandwidth high. So particularly in the case of optical fiber, in the range of terahertz, we can easily achieve. But here, which frequency spectrum we are going to use? So bandwidth is low compared with wired network. It's less. Again, this cost comparison, it depends on the application. Okay, less as cables are not expensive, more as where it's requires a router access point. For example, you can Wi-Fi, you need access point, and other connectivity is there. Installation. So wired network takes a long time. So wireless, you can easily immediately install. If you put 2-3 access point, means you can cover a few networks. So mobility, that is a major drawback of wired network. It is a limited one, and in the wireless networks, not limited. So as a transmission medium, coaxial cable and twisted pair, it's operating in the copper wires, and high bandwidth range, it's optical fiber cables. So wireless, it is based on the electromagnetic. The wired networks requires hubs and switch base station, or if you increase the power, transmission power, means the coverage area will be increased. And application, so n number of application, wireless LAN, wireless PAN, infrared, cellulars, like that, many applications are there. And channel interference and signal power loss. So the signal goes through the separate cable, so there should not be any interference. But in the wireless, so all the wireless signal, different frequency is there, but due to adjacent and co-channel interference is there in the cell phone. So like better, but in the wireless, it's poor due to high value of delay and jitter. environmental conditions will affect the data rate. So it's a continuously varying one. It's based on the and in the signal propagation ranges in the wireless networks, there are three ranges: transmission range, detection range, and interference range. So transmission range, so here within this range, in the first circle, communication is possible with low error rate. So that means receiver and sender, easy they can detection range, detection of the signal possible. That means receiver can detect the signal. That is the second range, detection range. Third one, interference range. So signal may not be detected in the third range, but it will add the background noise to the other channel. So suppose suppose we want to transmit the signal from one sender to another receiver, then only with a low bit error the signals can be transmitted. And in the wireless, it's mainly through the electromagnetic. The transmitter reaches to the receiver, because always direct path is not possible in the wireless to the receiver. So one is direct line of sight. So that means there is no obstacle between source and destination or sender and receiver. So directly the signal which will reach the receiver. Means also signal will reach to the receiver. The first one is called as shadowing. So shadowing means the receiver is behind the shadows of, for example, big hills or building. So behind that, the receiver is there. So it is called as signal strikes at the large opticals. So automatically the multiple reflections, the signal may reach to the receiver. And refraction. So refraction, again, it's based on like optical transmission. It is based on the density of the both the medium. So air medium and scattering. So scattering appears when electromagnetic wave strikes with the edges, like a signboard edges. The one wave is split into many waves. It is called as a scattering. And diffraction. So diffraction, like hills, like big buildings, its electromagnetic strikes means it's split into multiple waves. So by any one means or direct line of sight, and the signal will reach to the receiver. Then so what happens in the receiver side? So the signal can take many paths between the sender receiver due to reflection, scattering, diffraction. So here you can see this. The one signal directly reaches to the mobile, that is car is moving. Direct reaching, and the pulse strength also it will be high, and also quickly time also quickly it will reach. But at the same time, through scattering or through diffraction also, the signal reaches to the mobile unit. So here you can see this. So these two pulses are a line of sight pulses, so having a maximum amplitude. So other pulses are having some less amplitude. Is combined. Again, the combinations depends on how much phase it differs. If phase difference is like adding, means it will add, otherwise what will happen, and the signal will be subtracted. So it's based on other paths will be removed. So only the direct line of sight will be taken care. So always, so direct line of sight not possible. So through this any one of the methods like reflection, scattering or diffraction, the receiver will receive the signals. So then so next one, as I told, the modulation techniques are very, very important, because mainly we are using digital modulation. So now everything, including our voice signal, so everything is converted into digital. So, but the digital signals cannot be sent directly. So the basic three modulation, digital modulation, ASK, FSK, and PSK. So amplitude shift modulation is very simple. So for, we are going to transmit zeros and ones. So zero means there is no is transmitted. So without changing the frequency, zero means there is no transmission. So one means without changing the frequency, as it is the carrier. Simple low bandwidth, because we are not going to vary the frequency, and very susceptible to interference. So at the zero period, so some noise are added, means sometimes the receiver will identify it is like one, like that. So that is basic characteristics of ASK. And FSK, you can see this. So one means as it is the same frequency is transmitted. So zero means the frequency is reduced. So for zeros and one, to different frequencies are transmitted. So once the frequencies are varying, means you need a larger band. And PSK, so here, so we are not modifying amplitude or frequency, only the third parameter, phase is going to change. So always if a phase change, means you can see here from 1 to 0. So once the phase shift means the receiver have some complex, because you need some reference signal to compare the phase. So more complex and robust against the interference. So these are the basic three modulation. MSK is used in the GSM, and QAM, that is a combination of ASK and PSK. So like that, so many 64, 256 QAM, 512 QAMs like this. So many, so advanced techniques are there. But for all these three are the basic digital modulation techniques. And next one, as I told initially, so only the frequency spectrum is limited. So we have to effectively use the available frequency spectrum. So we should go for the frequency available. So available single channel, we have to send the signal, or we have to connect the multiple users. So the basic multiplexing technique is frequency division multiplexing or frequency multiplexing. Here you can see this. There are three axes: time axis, frequency spectrum is splitted into small frequency slots. Slot. So advantage, so no dynamic coordination is necessary, and it will be work for analog signal. So drawback, waste of bandwidth if the traffic is distributed unevenly in flexible and guard spaces. So that means here you can see this, the guard space is guard space means between the adjacent user. So we have to give some space. And always the users are not going to use 24 hours for the channel. For example, if we take our mobile also, 24 hours we may use maybe half an hour, 1 hour. If all the users permanently on frequency is allocated, means so remaining time it will be used. Spectrum to another user, because already all the filter design, the frequency oscillator, everything is spectrum. For example, K1 is having one frequency range. So you cannot allocate K1 to K2 or like this, for vice versa for K4 to K5 like this. It's everything is fixed. If a user is not using the particular frequency spectrum means it is a totally waste. Okay, so that is so here simple concept, small frequency spectrum, entire duration the user has to use. So next one, so here the opposite, that is the entire frequency spectrum is used by each user in the small time slot. Here the entire time is split into a small time slot. So each time slot is allocated to one user, but the frequency is not splitted, it's the entire frequency. So advantage, only one carrier in the medium at a time. So throughput high even for many users. So that means here all the users are going to use only the same frequency. So we are not dividing in terms of frequency. So all the users are using the same carrier. So here advantage, for example, 6 users are there. Suppose 3 users is not having any data means these 3 can be allocated to another 3 because the same frequency, same carrier frequency. Only we can merge 2 or 3 time slot. So that is advantage. That means only one carrier medium at any time. Throughput high even for many users. So drawback, because each user one particular time slot is there. If timing between the sender and the receiver not matching means, so for example, on the K1 time slot, K2 user will be connected. So like that, so confusion will be there. So the precious time synchronization is very important in the time division multiplexing. Next, code division multiplexing. So you can see here. So here entire time and entire frequency. So each user is allocated with one code, K1, K2, K3, like up to K6. So here all the as code division multiplexing, but here because the codes we have to generate with the orthogonal for with the multiple mathematical properties, so only the limited codes are available. So that is one of the drawback of code division multiple accessing. So advantage, bandwidth efficient, so no coordination code, good protection against interference and tapping, because and the frequency division, time division, if you know the time slot or frequency means the signal can be the code. So that is a good protection against interference and tapping. Drawback, low user data rates. So you can ask, code multiplexing uses entire frequency and time. Here one drawback is if number multiplexing, the data is going to reduce. So due to that the code properties, and more complex signal regeneration implemented using spread spectrum. So these are the basic concept, but later when you are going for the real implementation, the advanced codes and very complex codes will be generated. And IEEE 802 is for the networking. So just you should know, because any network will be belongs to any one of the one is for inter-networking. So inter-network means how should connect, how can you connect with two computers, because if earlier individual computer interconnecting, you need a standard. So that is IEEE 802.1, and 802.2 is a logical link control. You know that that second layer is split into MAC and LL.2, and .3 is a CSMA CD. So carrier sense multiple access with collision detection. So that means by many users, then we need some techniques, that is the carrier sense multiple access with collision detection. 4 is token bus. So it's a bus networks. So whoever want to send the data, so they have to capture the bus token. So then only they can send the data. And 802.5 is a token ring. So many logically connected in the ring format. So here also for sending the data, token ring standard. Then IEEE 802.6 is Metropolitan Area Network MAN, and 802.7 is broadband LAN. So 802.3 is normal LAN network. So 802.7 is broadband LAN, and 802 media for this dot 3 and dot 7. Actually dot 3 initially developed for coaxial cable, and dot 7 they are using for physical media as a fiber optic cable. And 802.9 is integrated, that is voice and data service WAN. You know that initially actually telephone was designed for happened through telephone only. Now we are all the data are we are sending. Similarly, internet network initially designed for sending the data, but now we are using for voice transmission. So voice and data having different properties. So for voice transmission, so error is there is no problem, but there should not be any delay. If delay is, you cannot there is no issue, but there should not be any errors. Like this, different Cat 6 are there. So if you want to integrate voice and data, means you need definite separate standard, that is IEEE 802.9. Then IEEE 802.10, it deals with the security aspects of LAN and WAN, and 802.11 is wireless LAN. So whatever it's displayed in the blue color, these are all related to wireless networks. So wireless LAN, then it's a CSMA CA concept, and wireless LAN also various subdivision also there. And because you can see this in the previous one, dot 3 also LAN, dot 7 also LAN, dot 8 also fiber optic LAN and MAN, but it supports up to some megabits. But here IEEE 802.12, it's a basic data rate itself 1 gigabits per second, and 802.13 100 base X Ethernet standard. And again the wireless area, IEEE 802.15 is PAN networks. So PAN means under this Bluetooth, Zigbee, like this communication are coming under IEEE 802.15. So IEEE 802.16 is for broadband wireless access system, that is for WiMAX. And IEEE 802.17 is resilient packet ring. So that means here uh, the optical fiber cable is proposed for the LAN. The resilient means if it's three rings are connected with each and every node. If any particular ring, any ring broken, means automatically it forms a so alternate ring. So that is called as resilient packet ring. And IEEE 802.18 is technical advisory group. So it mainly deals with the already many working groups are there. 16.20. So it deals with all the networks. And IEEE 802.19 is coexistence technical advisory group. So coexist means so many unlicensed devices are there, wireless device. So it deals the how the unlicensed devices, wireless devices will coexistence. So it deals with that factors. And 802.20 is mobile broadband wireless access, and IEEE 802.21 is media independent handoff. So within mobile, it's a handover. It's a horizontal handover. Vertical handover means, so for example, when you are in the home, your mobile phone is working with Wi-Fi. When you are leaving, means automatically it should be switched on to Wi-Fi or any other wireless connection. So that is called as media independent handoff. And IEEE 802.22 is wireless regional area networks. That is WRAN. So out of this, on the dot 11, dot 15, dot 16, dot 18, dot 20, and dot 22. So these are all belongs to the wireless network standards. And types of wireless networks, again, we can classify, it's barely depends on the personal area networks, very short range. It covers few meters, maybe up to 40 to 50 meters. Cables for peripheral, for example, keyboard, mouse, like this. The standard Bluetooth, Zigbee, and NFC. Building or 1 kilometer, maybe within a campus. Applications, it's extension of wired net 11, and many subdivision like A, B, N, like that. Many variations are there. And man network, metropolitan area, as city. And applications, wireless internet connectivity for WiMAX. And wide area network, it's a worldwide example, our cellular networks. Okay, if you want, you can connect entire world by splitting all the areas into small cells. That is UMTS, LTE, GS. And the Wi-Fi also wireless LAN 802.11. So dot A dot 802.11a, because it's based on the user requirements, we have to give high data rate. So for that, they modified the modulation techniques. It's initially, I think QPSK used, then QAM, so then spread spectrum. So like this, then YFDM is used. So based on the modulation techniques, the data rate is improved. So that's why the various Wi-Fi standards. So currently 802.11 up to version W is there. And PAN networks, so personal wireless area network, its standard is IEEE 802.15 under PAN network. So Zigbee standard is IEEE 802.15.4, and subdivision also the .4a, .4b is there. So Bluetooth 802.15.1, and broadband, so wireless man IEEE 802.16. So it's, I think more expertise is on their WiMAX, because for high internet connectivity, people initially proposed WiMAX, but currently after 4G, slowly the importance of WiMAX is currently getting reduced, only for point to point. Want wireless means we can go for WiMAX. For individual users, instead of WiMAX, So now they are preferring 4G or 5G network. So all the four sides have four different parameters. So bottom side is a variation of data rate from few kilobits per second up to basically some 500 megabits or up to 1 gigabits per second. Starting side, the coverage area, short range from few meters to kilometers, short range to long range. To four types of pan, LAN, MAN, WAN. So it belongs to which one? And the top side, so what are the applications supported by the particular network? So there are four sites are there. First, you start with Zigbee. By seeing this position, you can understand the properties of Zigbee. So Zigbee supports very, very low data rate. Normally, Zigbee supports only a few kilobits per second, and it coming under PAN network and applications. So it's a purely text or graphics, some minimum internet speed it will support, and is also coming in the PAN network, but the data rate is somewhat high. You can see this for headphone, for continuously listening music, we are using headphone. So Bluetooth headphone is there. That means in terms of 1 or 2 megabits per second, you can send the data. So it's also belongs to PAN network, medium data rate. Application, you can see this, it will support hi-fi audio and also streaming video is there. So next Wi-Fi, all the versions, it is starting from 802.11 version A. It's a medium data rate, medium. The latest version is improved, and the streaming video also it supports. And WiMAX, you can see this, it's a right side. So that means it belongs to MAN and video, multimedia video. So like this, the high data rate applications also, it's a 2G and GPS 2.5G. So here the distance wise very long distance, and it supports text, graphics, and internet. So you know that initially 2G, GSM, CDM, and all, just we can send the SMS. In the 2.5G, we can get up to 30 to 40 kilobits per second speed for internet, and streaming video, digital video like this. So now currently maybe 5G may be in this right corner in this position. So 5G definitely it will support the multiple channels of video. So it supports in the 1 gigabits per second. So using this single diagram, you can understand what is the role of each and every wireless network. Another site is based on the coverage area PAN. So that means within MAN, LAN will be there. So within LAN, the PAN will be there. And we will see one by one. That's the basics of the Bluetooth. What are the applications? So you can see this centrally laptop is there. So it will be connected to all these devices. Maybe you can particularly it will replace the cables, personal computers, printers, mobile phones, hand-free headsets, LCD projectors, modems, wireless lab devices, notebooks like this. So wherever for short range we are using cables, for instead of short range cables, it will be connected with the Bluetooth. So that is main applications of Bluetooth. That's band. So this 2.4 is also coming under ISM band, that means industrial, scientific and medical applications. So for using this frequency, no need to get permission from the government. So that's why, so all these PAN there's no need to get permission. That then if you transmit higher power means automatically it will create interference to the other persons. So that's why for all the PAN network in the particularly in the ISM band, the transmitted power is also limited. So here the Bluetooth transmit power is only 1 milliwatt, but in the case of cell phone transmitted, it may be up to 500 milliwatt, low cost, coverage range 10 meter to 100 meter, and it uses frequency of spectrum, data rate 1 to 2 mbps, and in a single piconet it will support 8 devices. Suppose if you want to connect more devices, you can form more piconet. It's called as a scattered net. Built-in security also there. So here one advantage, no need of line of sight. So transmitter and receiver may be in the different position. So there obstacles also may be there. So within this range, it will work. It will work in the non-line of the integration of TCP/IP for networking. And Zigbee, next PAN, important PAN is Zigbee, because currently after the development of IoT, particularly in the sensor networks, Zigbee protocol is mainly used. So before was formed. So then what is the mission of the Zigbee Alliance? So Zigbee Alliance is an association of companies working together to enable reliable, cost-effective, low-power, wirelessly networked monitoring and control products based on an open global standard. So each and everybody is here a very, very important one. So what is Zigbee together to enable reliable? So reliable means so 100% reliable transmission packet should be the reliable and cost effective. So very less cost we have to transmit the data, and low power. So already we have seen it is under PAN network, so the power will be should be low, and it's a products. So particularly the Zigbee used fast for the just to switch on, switch off the electronic devices. So in our home also we have remote is there, television separate remote. So like this, we have many remote control is there. If you connect to Zigbee, so monitoring and control products based on open global standard. So if you purchase any product in particular country, it should work with the so other countries. So main applications, industrial and commercial sites, that is controlling monitors, sensors, and automation and control. Automation means just switch on, switch off based on some parameters. Consumer electronics. So consumer electronics, that is controlling of television, VCR, DVD, CD, remote control like this. And here PC peripherals. So you can remove cable in the mouse, keyboard, joystick, but instead of wires, you can use Zigbee protocol. And home automation. Home automation, just opening the doors, closing the doors, or switch on the light, switch on, switch off the light, door like this. For just on-off applications, we can use home automation like security. Security means like switch on the light or camera like that. Then high voltage AC transmission, lighting, and closers. And in the toys and game side, pets, game boys, educational toys, you can use Zigbee. And personal diagnostics and some medical sensors are also can be connected with Zigbee. I think the next session also will be there in this use of IoT and its applications. So there you can you should know the importance of and the next one is first to Zigbee and Bluetooth we covered. It's coming in. We have various standards. Just I pointed only the 4 important standards. The basic is IEEE 802.11a, 11b, and .11g and .11n. So data rate 54 Mbps, 11 Mbps, 54. Current for 2 by 2 antennas. Throughput 23 Mbps, 4. Megabits per second. So operating frequency gigahertz. 11B and 11G is at 2.4 gigahertz. 11N operates both either in 2.4 or 5 gigahertz. So compatibility, if various IEEE standards are there, suppose compatible or not. So this is the first one. So 11A. So there is no problem in compatibility. And 11B, it compatible with IEEE 11G and 11B and 11. It will work both all the three 11A, 11B, and 11. 11A is 35 to 120 meters. 11 same range. 11N 70 to 250 meters. Again, it depends on the number of users and transmitted power. And the number of channels, 11A 3 channels are available, 11B up to 23 channels, 11G 3 channel, and 11N it's a 14 channel. And what is the transmission? B direct spread spectrum, and 11G direct spread spectrum or YFDM, and 11N is a MIM, that is a multiple input and multiple output. So this is a wireless LAN standard. And next one is wireless MAN, that is called as WiMAX. So WiMAX means its expansion is worldwide interoperability for microwave access. So initially, for long distance transmission, I think 20 years or 15 years back, so all these television studios are connected with micro link. So micro link means every 20 to 25 kilometer one micro tower is there. So through this micro tower, so continuously the signal will reach to the other studio. So from there the signal is transmitted. So here satellite communication in all the applications, this micro link is uh, removed. So the WiMAX means worldwide interoperability for micro access. So whatever applications supported for that microwave, the same thing will be supported by the WiMAX. So here, so WiMAX is a broadband wireless networks based on IEEE 802.16 standard, and it have a range of 31 miles. So primarily for making broadband network access widely available without the expense of stringing wires or the distance limitation of DSL. So already in the wired for broadband we have DSL network is there. So it the objective is to replace the DSL with WiMAX and area networks. So all these cellular are coming under wide area networks. So first generation means it's a purely analog signal. It is circuit switched. So there are two standards developed in 1G, AMPS advanced. Drawback is it is purely analog, and also modulation also only frequency modulation is used. So for each user, one frequency band is allocated. To get your phone signal, they tune the frequency, means they can access your voice signal. So there is no security implemented. So only it's purely for voice. And later, second generation, it's a digital one. So once a digital means you can use for any application. So any, it may be message or any audio or any video file, you can convert into 0 and 1. So you can also such circuit switched global system for GSM kilobits per second. Actually, exactly it is 9.6 kilobits per second. Here the concept is both FDM and TDM is used. So initially, the allocated bandwidth for each service provider, it is divided into small frequency spectrum. Then each frequency spectrum is divided into number of time slot. So each time slot is allocated to one user. That is, it is a combination of FDMA with TDMA. So that is a concept of 2G. There, security is provided up to the air interface. So that means from user to base station, base station to mobile switching center, GMSC. So there is no security. So that is a drawback. So primarily, one of the killer application of 2G is SMS. In 1G there is no SMS. So 2G we can send the message SMS. Their data rate is 9.6 kilobits per second. Then 2.5G. Actually, why before 3G, why people went for 2.5G means data communication. So what they propose, one channel is 9.6 kilobits per second. Suppose if you want to use for data transmission, you can combine 2 or 3 time slots. Of 3 into 9.6 kilobits per second. So you can use digital packet switch, TDMA, GPRS, and edge like that is yes. But here the 2.5G only few years only it is useful, because if you want time slots. Suppose if you want to 400 kbps means at least 40 time slot you have to combine. So 40 time slot means it occupies the 40 users voice communication slot. So that means if everybody is using for voice data applications, there is a scarcity for people immediately change to third generation. Here it is at 100% digital packet switch. So mainly the wideband CDMA technology is used, and also UMTS. The data rate varies from 0.4 to 2 Mbps, and currently we are using 4G networks. Long-term evolution is there, but practically again this we are not achieving 100 mbps, maybe up to 2 mbps we are going to achieve. Again it depends on the particular base station, and again based on the external conditions. So it depends on many parameters. And the 5G in some places it is for testing purpose, it is already developed or it is established. It is a 5G new radio. So new radio means than this 4G. So there the specification is minimum is 1 gigabit per second. So I think definitely we can get 100 Mbps. So if everything is implemented practical, so definitely we can get 100 Mbps. So these are the developments of in the cellular generation. So we started with what are the difference with the wireless and wired communication, and what are the digital modulation technique used, and what are the multiplexing techniques, and then IEEE standards related to networking, then related to wireless, how the networks are classified like to PAN, WAN, PAN, MAN, WAN, then like this. Then each PAN means what are the currently wireless networks like Zigbee, Bluetooth available. So LAN, so Wi-Fi, what are the various standards? So MAN, it's a WiMAX is there. Okay, so and this is cellular, so up to various fifth generation mobile networks we have seen. So these are the very fundamentals. For understanding the remaining sessions, definitely you need some overview of all the fundamental. I think next session onwards, the each and every wireless networks will be discussed in detail. So thank you. If a chat box, or you can enable your mic and you can ask.
Dear participants, if you have any queries, kindly post your queries in chat box or unmute yourself. Sir, in chat box there is a question: what is hi-fi audio?
What is the
Hi-fi
question?
audio. What's hi-fi audio? There is a question.
Yes, actually in the audio link initially it is only mono. Mono means only one channel is there, and after that stereo. Stereo means only two channel. So hi-fi audio means you can. For example, voice, and we are using 8 instrument means all the 8 instruments having 8 channels. So if you increase the number of channel, the music will be highly quality one. So that's it. And one more question: what range of frequency can be used for research purpose and for already for a PAN, LAN, MAN networks already frequency is allocated. As I told, is this 2.4 gigahertz is under ISM band. So for research purpose, you can use 2.4 gigahertz.
Dear participants, if you have any other questions, kindly post your questions in chat box or unmute yourself and ask the queries to resource person. So I think there is no more questions there. Shall we
Okay.
conclude the session, sir?
Yes, you can conclude and post the feedback and attendance link.
Okay, sir. Thank you.
When educating the minds of our youth, we must not forget to educate their heart. In this way, I would like to thank our today's resource person, Dr. R. Ashokan, Professor of EC and Principal of Kungunadu College of Engineering and Technology, for providing a wonderful session on the topic of Introduction to Wireless Network. Thank you so much, sir. Dear participants, the day 1 session 1 attendance and the feedback link is posted in chat box. It will be open up to 30 minutes only. So kindly fill it soon. While filling the feedback form, kindly select your respective STTP ID. Thank you.